So we all know AI can whip up a software prototype in like minutes. It's incredible. But the real question is, can you actually trust that code? Can you put it out there for real users? That's what we're going to dig into today. How to take that super fast AI prototype and make it something you can actually count on.
All right, so you've got this awesome prototype. It looks great, but I love this question. Would you actually live in it? Think about it. An AI can throw up the digital version of a house at lightning speed, but is the foundation solid? Is the wiring safe? Or is it just a pretty shell that's going to fall apart? That's the heart of the problem when you go from a cool demo to a real-world app.
And this is where we have to totally shift our thinking. You know, in this new world of AI coding, getting that first working version, that's kind of the easy part now. The real work, the stuff that makes the difference between a solid product and a flimsy toy, that all starts when you try to get that code ready for the real world. It really forces you to rethink your job as a developer.
Yeah, and this quote just hits the nail on the head. You're not just a feature builder anymore, cranking out one thing after another. Nope, your job becomes more like a system orchestrator. You got to step back, look at the whole thing the AI spit out, and make sure all the pieces are actually working together. You're the conductor, making sure the whole orchestra sounds good, not just playing your one little instrument.
I mean, it makes sense, right? These AI tools are built for speed. They're designed to give you something that works immediately. And to do that, they're going to take shortcuts. That's fantastic for a quick prototype, but it can leave behind this hidden mess of problems, you know? It's exactly like that house built in a day. It looks fine, but the foundation might be a total disaster.
And that hidden cost, that mess under the surface, it actually has a name in the software world. We call it technical debt. I love the analogy of an invisible mortgage. Every time you take a shortcut for a quick win, you're essentially taking out a loan, and you will have to pay it back later, with interest in the form of headaches and rework.
So yeah, here's the more formal definition. But what does that actually mean in practice? Well, every time you or an AI just jams a value in there instead of doing it properly, or skips writing a test, or just creates this huge tangled mess of code to make something work, you're racking up that debt. You're basically guaranteeing yourself a massive headache down the road.
Okay, and what's super useful is breaking this debt down into different types. First, you've got architectural debt. This is like building a house with no internal walls. It's just one giant room. If you change anything, it affects everything. Then there's test debt. That's like deciding, who needs smoke alarms? Everything's fine until there's a fire. And then there's documentation debt. That's your house with no blueprints. Good luck fixing anything when you have no idea where the pipes.
But wait, it gets trickier. Technical debt is something we've been dealing with for years. The new wrinkle is when AI isn't just a tool, but an active partner, what we call an agent. This brings a whole new set of risks to the table. It's like your contractor is a genius, super fast, but also completely unpredictable and occasionally just invents things.
So in this agentic workflow, where the AI is doing the planning or the coding, we can't just look for normal bugs anymore. We have to be on the lookout for the very specific ways an AI can mess up. We have to actively hunt for them, because trust me, they can fail in ways that are totally different and way more subtle than a human developer ever would.
And this slide really shows the contrast. We know how to handle standard bugs and project delays, but now we're dealing with stuff like AI hallucination, where the AI just confidently makes up a function that doesn't exist. Or even scarier, prompt injection, where someone could trick your AI into running malicious code. These are whole new ball games that need a completely new playbook.
Okay, so with all this old school technical debt and these new spooky AI risks piling up, how do you keep the whole thing from just crashing down? The answer is surprisingly simple. You have to pause. You take a breath, and you hit a big old reset button by doing a proper architectural audit.
And I love how this source material puts it. This project reset isn't about saying you failed. Not at all. It's a strategic move. It's a pit stop to check the health of your application's foundation. It's just smart. You wouldn't add a second story to your house without making damn sure the first floor can take the weight, right? Same idea.
And this isn't just some vague concept. It's a methodical three-step inspection. Step 1, you analyze the code base. You really get in there and see what's what. Step 2, you identify the debt and the risks. You find all those specific problem spots. And finally, step 3, you classify and document them. You categorize every single issue so you know exactly what you're up against.
This whole audit process is a huge part of a philosophy called vibe coding. It's all about keeping a human in the driver's seat. VIBE stands for verify, improve, build, and execute. It's a really simple but powerful idea. You verify whatever the AI spits out.
You improve it to meet your standards. You build on top of that now solid base, and only then do you execute it and put it into production.
All right, so we found all the cracks in the foundation. We know we need to fix them. Now for the final and most important part, how do you turn that list of problems into an actual plan? How do you create your renovation blueprint?
And this is absolutely crucial. An audit that just ends up as a report collecting dust on a virtual shelf is completely pointless. Seriously, a total waste of time. The whole point is to operationalize it, to turn those findings into actual tasks that your team can pick up and work on. You got to make the problems real and solvable.
And this is how you do it, step by step. First, you figure out what's most important to fix. Then, you turn each of those items into a ticket or an issue in your project management tool, like GitHub. You tag it, technical debt, refactor, whatever, so it's super clear. And here's a cool little trick. You can even get an LLM to help you write the criteria for what it means to actually fix the issue. It's like making the AI help clean up the mess it made.
And that's really the whole story, right? You start with something that was built incredibly fast, but is also probably pretty fragile. But by going through this methodical process, auditing, planning, and then acting, you transform that fragile prototype into something truly robust and production ready. You're not just patching up a shack, you're building a skyscraper on a solid foundation.
So let me just leave you with this final thought. Take a really honest look at the project you're working on right now, especially if you're using AI. What's holding it up? Is it a solid foundation you've actually taken the time to inspect? Or are you just stacking another floor on top of a house of cards? Because honestly, the answer to that question could be the difference between success and a spectacular collapse.